Okay, in this video, I'm going to cover Newton's divided difference formula and Newton's forward and backward divide difference formulas. So first one, let's take a look at this. Newton's divided difference formula with equal spacing. So equal spacing means that the nodes are equally spaced. So let's say the h is the distance between two consecutive nodes. So as you can see that let h is equal to x of I plus 1 minus x of I, the right here. Okay, then give me a second. Yeah, so see, let h is equal to x of I plus 1 minus xi. So I goes 0 through the n minus 1. So now that since the nodes are spaced equally spaced, so we could express the input x value x. We could express input variable x in terms of the h0, which is the first node, and the length h. Okay, so like this: x0 plus x sub 0 x sub naught plus s times h. Okay, so here s is a new variable. Okay, so and the definite s is the real number, right? Okay, so now then if you don't get it, you can, as you can see right here. So let's say this is the number line. Okay, let's say here's x0. Okay, here's x0. All right, and then here's x1. Here x2. Okay, all right, 2, and then through the here's xn, right? Okay, xn. Then for any what the for any x value, let's say x value is x value is right here. Okay, so right there. Here's x. Okay, then the this x can be expressed as in terms of x0 and h, like this: x0 plus. Okay, so definitely the what plus, and then definitely we have to add more than one h, right? Because from here x0 through the x1 is h, right? Here h. Okay. What about the length from the x1 through the x? That's gonna be just you know the proportion of the what h, right? Okay, we don't know, but we could say just some the the value s, which represent a proportion of h, right? Okay, so s times h. Okay, so here in this case s must be what 1 plus the proportion of h, so maybe 1.2 or 1.5, something like that. Okay, so now then no. So then what about the x minus xi? Then x minus xi going to be x0 plus sh minus, and then x0 plus ih. Now you see that for any the nodes, we could express the nodes in terms of x0 and h. So xi going to be x0 plus ih, right? So simplifying this, then we're going to get this s minus i times h, right? So what we're going to do now, we're going to apply this one into the algebraic expression of the nth degree Lagrange polynomial. So give me a second. So Pn of x was this what a0 plus a1 times x minus x0 plus x2 times x minus x0 times x minus x1 is plus 2d plus an times x minus x0 times x minus x1 times 2d x minus xn minus 1. Remember that? Okay. Let me see. Okay. So now then, give me a second. So now, using the Navier's method, we can figure out the A0, A1, A2 through the AN, right? So A0 was the apple bracket x0, right? And plus A1 was the f of the x0, x1. Let's divide the difference notation, right? Times x minus x0, then plus f of bracket x0, x1, and x2 times x minus x0 times x minus x1. Excuse me. So and then just adding skip until f of bracket x0 and through the xn, right, times x minus x0 through the x minus xn minus 1. Okay. So now then the here now we're gonna uh the replace x minus x0, x minus x0, x minus x1, all the binomials by the what, this one, s minus I times h. Okay, so this is equal to f of, because x minus xi was what? That was s minus I times h, right? So f of x0 plus f of x0 comma 1, oh, x1 times x minus x0 going to be what? S minus 0 times h, right? So sh plus the x0 comma what? d1 x1 comma x2, and the x minus x0 was what? S times h, right? And the x minus x1 is what? X minus x1 is what? S minus 1 times h, isn't it? S minus 1 times h. Okay, and then plus the f of x0 through the x3, s minus 1 times s minus 2 times, that was, I'm sorry, sh, s minus 1, h times s minus 2, h, isn't it? Okay, so keep going. Now, let me simplify this one and this one. Okay, so now here, the sh times s minus 1h, okay, this is equal to s times s minus 1 times h cubed, right? H squared. Okay, and then this one is what? S times s, h times s minus 1 h, and the s minus 2 h. This is equal to s times s minus 1 times s minus 2 times h cubed. Is it? Right? So now we can say that this is equal to what? Let me see. F of divide difference, okay, plus f of divide difference f and x0 and x1 times sh plus f of x0 through the x2 times sh square. You see? And then plus divide difference of x2, x3 times s times, oh, I'm sorry, this is s, not sh square. S times s minus 1 h square, right? This is s times s minus 1 times s minus 2 h cubed. Is it? And then plus what's the last term? The last term going to be what? F of x0 through the xn times s minus 1 times through the s minus n plus s minus n minus 1, which is s minus n plus 1, right? Or we can say s minus parenthesis n minus 1 times h to the nth power. Is it? Okay. So now then, so since the what except for the first term, the all terms have the pattern. So we could express the piece of n, the algebraic expression of the alternative algebraic expression of the nth degree Lagrange polynomial as like this. Let's see. It's like this. Right here. The what? So the difference of f at x0 plus sigma, okay, s times s minus 1 through the s minus k plus 1 times h to the k's power, okay, and the k moves from 1 through n, and then the difference of f at x0 through the xk. Okay, now then, see the s times s minus 1 through the s minus k plus 1, that's actually what? The combination of k out of s, right? So that's the this k factorial. Okay, I mean, we could express the what? The s times s minus 1 through the s minus k plus 1 in terms of the combination and factorial. Okay, so the combination s and k definition is what? S times s minus 1 through s minus k plus 1 divided by k factorial, and then multiplied by k factorial, we're gonna get the the product of the what? S through the s minus k plus 1, right? Okay, so we can simplify. We can more simplify the expression of the this one, Newton's divided difference, is like this. So next one is Newton's forward divided difference formula. So now the here, so the first one, I'm gonna introduce new difference notation. Okay, so it's what? It's called the notation. Name of this one is Nabra. Okay, so Nabra f of x0 is equal to f of x1 minus f of x0, and Nabra f of xj is equal to f of xj plus 1 minus f of xj. Okay, so the Nabra f of x0 is the difference of f of x, the x sub the sub index, which is 1 greater than the 0, in general 1 greater than j. Okay, so you see that f of Nabra f of xj is what? Difference of f of xj plus 1 and f of xj. Okay, keep in mind this. So now then, we could express the divide difference using the difference notation Nabra. The definition of divide difference of the f of f of the bracket x0 x1 is what? F of x1 minus f of x0 over x1 minus x0. But look at the numerator. F of x1 minus f of x0. This can be expressed as what? Difference notation Nabra f of the x0, right? Okay, and then x1 minus x0, assuming that the nodes are equal space, then x1 minus x0 is nothing but h. Okay. Now, what about the divide difference of f at x0 through x2? Similarly, we could express the numerator see that here, right there. First one, we what express f of x1 and x2 as the what the f of x2 minus f of x1. I mean divide difference, okay, over x2 minus x1, and then the second term in numerator is this, that expression, that's fraction, right? Okay. Then what about the denominator x2 minus x0? That's a 2h, right? So we take out 2h right there, 2h. And the first term is what? That's the divide difference of f x1, x2. The second term is what? Divide difference of f at x0 and x1. Now, the what? F of x2 minus what? F of x1 is the nabla f of x1, and then the numerator in second term, numerator is the second term is nabla f of x0, right? Because f of x2 is nothing but, I mean, divide difference of f of x2 is nothing but what? Just f of x2, right? Then divide difference f at x1 is what? F of x1. Okay, so here that numerator is nothing but f of x2 minus f of x1. Using the difference notation nabla, we can say that this is the what? Nabla f of x1, right? And similarly, we can say that this one is nabla f of x0. And then the these two fraction has a common factor, 1 over h. So factoring out, so we're going to get the 1 over 2h squared. So then nabla f of x1 minus nabla f of x0, that can be shortened. Okay, that can be expressed shortened as like this, nabla f of x0, right? So we got the nabla square f of x0. Is it make sense? So now then, now you see that here pattern for that divide difference, we got the 1 over h times nabla f of x0. For this one, actually what? I mean, well, yes. Actually, this is what? That is the a. Oh, and that is a a1, right? The unknown constant a1, unknown coefficient a1 in the alternative algebraic expression, right? And then this is the actually what? A2, right? A2. Okay. So keep going. So then what? In general, we can say that what? Oh, yeah, we can say that the you can see that what? Divided difference of f at x0 through the xk is 1 over k factorial h to the kth power times nabla kth power of nabla of f of x0. Okay, so now that's the alternative expression of the divide difference. Okay, I mean this is a Newton's forward difference. Why is Newton's forward difference? Because we express the what? Let me second. Express the divide difference f in terms of the f of x0. Okay, we're gonna apply the divide difference from the x0. Okay, that's why there's a Newton forward difference. Now next one. Yeah. So, okay. Now then what? Okay, so then finally fpnx is equal to pnx0 plus sh. Now we're gonna combine. Remember that. Okay, give me a second. So now here see pn of x, that is equal to was pn x0 plus sh, right? Okay, because we assume that nodes are equally spaced. That was f of x0 plus, and then what? F of x0, x1, and then s times h plus f of x0 through the x1, x2 times s minus 1, h squared plus f of x0 through the x3, s times s minus 2, 1 times s minus 2, h cubed plus through the f of what? X0 through the xn, then s times s minus 1 through the s minus n plus 1, then h to the nth power. There's an nth power right there. So now we're gonna replace this divide difference with the what? Newton's fourth difference notation. Okay, Newton's fourth difference formula. Okay, so this is equal to f of x0, right? And then plus this one was what? The Nabra, what? This is the Nabra f of x0, right? sh. And then plus that one is what? Nabra square f of x0. The s times s minus 1 and h squared, right? Keep doing. The last term gonna be what? The Nabra, what? Nth power, right? Number nth power, and then what? F of x0, right? And then s times s minus 1 through the s minus n plus 1 to the h to the nth power, right? Okay. So now, in second, yeah. So this is not I made what here Nabra f. Yeah, there's I made a mistake. This is not just Nabra square f of x0, but this is going to be 1 over 2h squared, right? I'm sorry. Okay. So not just the Nabra nth power, but just going to be 1 over n factorial and then h to the nth power. Okay. So, okay. Now, let's see. Okay. Now then, this is equal to, yeah, let me express this one with the summation. Okay, sigma. This is going to be equal to f of, I mean, that one is nothing but f of x0, okay? And plus, and the sigma k goes 1 through the n, right? And then the what? The Nabra f of x0, I mean Newton's fourth difference formula can be expressed as what? 1 over, right? 1, let me write down here, 1 over k factorial h to the k's power, and then Nabra k's power, and then f of x0, isn't it? Okay. Then what about this then? S times h, s times, s minus 1 times h squared through this. That's going to be, we express this one in terms of the what? The combination and factorial, right? S combination s and k, right? And then k factorial, right? That's the what? That's the s times s minus 1 times through the s minus k plus 1, right? Okay. So now then, you see k factorial times the what? The h to the k's power. Okay. So now it's the k factorial h to the k's power, and the 1 over k factorial times h to k's power cancel them out. So this is equal to f of x0 plus sigma k is equal to 1 to the nth power, and then combination s and k, and then Nabla case power f of x0. Okay. Right. So this is alternative way. I mean, this is alternative way to express the alternative algebraic expression of the nth degree Lagrange polynomial using Newton's forward difference formula. Okay, so that Nabla f of x0, that's the Newton's forward difference formula. Okay, so now next one. Okay, now next one, the Newton's backward difference formula. So in Newton's backward difference formula, you can see that we're gonna reorder the interpolating nodes from last to first. It's like this. Okay, so and then we're gonna express the input value, input x value, and all nodes in terms of xn. Okay, so then the first one, look at this. We're going to consider the x sub n as the first node. Okay, then we're going to consider x sub n minus 1 as the second node from first. Then Pn of x can be expressed as like this. So x minus x, f of x, you divide difference f and xn, and divide difference f, xn and xn minus 1 times x minus xn through the last term right there, right? And then this divide difference, for example, this d what? F of xn minus 1 minus f of xn over x sub n minus xn, right? Okay. All right. Then let's so here also we assume that the nodes are equally spaced. Then we can say that x is equal to xn plus sh. And then the xn is what? Give me a second. See. Yeah, so now here, x0, oh, let's see that. Yeah, x0 is equal to xn minus n times h, is it? Right? The x1 going to be xn minus n minus 1 times h, is it? Okay. Through the, yeah, give me a second. So right here is what? This is the, second. So x0 is equal to xn minus n times h. How come? But yeah, this is x0 and here's xn. Okay. Then here's x1, here's x2 through the xn minus 1, right? So what's the difference between x0 and xn? How many h's between x0 and n? There are n h, right? This is for h, this is h, right? Through the h. How many h between x0 and xn? N h, n times h, right? So there are h n times, right? So we subtract the n times h from xn, we're gonna get x0. That makes sense, right? What about the x1? x1 is what? xn times xn minus n minus 1 times h, right? So similarly, what? xi is what? xn minus I minus 1 times h, isn't it? So then x minus xi is equal to xn plus s times h. This is the other expression of h, right? X, right? Minus xi is what? We plug in this one right here, xi. Then we're gonna get xn minus n minus I times h. Okay, right? And to simplify this expression, we're gonna get the s plus n minus I times h. So now that's why, see, so that's why we got this. X is equal to xi plus s plus n minus I over h. Or we can say x minus xi is equal to s plus n minus 1i times h. Okay. And now, yeah. So now then, p and x, let's see, is what? This is going to be pn of xn plus sh. Okay. So you can say that. All right. So here, but what is s? S must be negative number, right? Okay. So because we what? Yeah, it could be positive number. Okay. So yeah, it could be any real number. Yes. This is equal to f of xn plus sh times. So yeah, we're gonna start from the what? The this one. Start from that expression. Wait a second. Yeah. You see this expression. Remember that? Okay. So since we assume that the nodes are equally spaced, so we could express the polynomial terms as in terms of the binomial coefficient notation and factorial, or we can say combination and factorial notation. Okay, so the and then we're going to apply the what Newton's backward difference formula into the divide difference notation. Okay, so so let's see. Yeah, right here. So now then, for the backward difference formula, we're gonna use the what the what the actually this is gradient notation, right? Yeah. So here, I need to correct the name of that symbol. Which one? This symbol in the Newton's forward difference. This is delta, right? That's not nabla. I'm sorry, I made a mistake. Okay, this is the delta. So and then that is the nabla. Okay, nabla. So we use this one as the gradient in calculus, right? So I'm sorry for that. So we're gonna use nabla as the backward difference formula. Okay. So now nabla Pn, this one defined as this one, Pn minus 1. And the higher power are defined recursively by what nabla, the case power Pn is what nabla times nabla to the k minus 1 Pn. Okay. So now then, the implied this definition, okay, is a backward difference formula into the divide difference formula, then we're gonna get this. F of x n comma xn minus 1 is equal to 1 over h times nabla of f of xn. Right? And then for this one, for that divide difference, it can be expressed as 1 over 2h times nabla f of xn and xn minus 1. I mean, can you see that? Why? Here, you see, the f of xn, xn minus 1, and xn minus 2. I mean, out of blue, where that comes from? Why we the orange the nodes like this, not xn minus 2, xn minus 1, xn? Because here we what? Here we set that we rearrange the order of nodes as from the xn through the x0. Okay. So now that's why the order of the nodes in here in divide difference formula. So this is equal to what f of the what? What is this? F of x n. Let me see. Yeah, this is f of the divided difference f at xn minus 1 comma xn minus 2 minus f of the xn comma xn minus 1 divided by, see that, xn minus 2 minus xn. Oh, so now this is here, that is equal to, okay, the top one gonna be what? This is gonna be f f of f xn minus 2 minus f of xn minus 1 over xn minus 2 minus xn minus 1, right? Minus f of xn minus 1 minus f of xn over xn minus 1 minus xn. Then over bottom one is what? 2h, minus 2h, right? Minus 2h. So this is equal to, what about top one? Top one is the what? This is equal to what? Let me express. I mean, the top one is what? The number f minus number what? F of x, the n minus 1, right? You understand that? So the top one is what? Actually minus f of x n minus 1 minus f of x n minus 2 over the bottom one is what? Negative h, right? Okay. Minus the second fraction is what? Minus f of xn minus f of xn minus 1 over negative h, and divided by negative 2h, is 2h. So now that is equal to what? So negative and negative cancel them out, negative and negative cancel them out. The top one, this is what? Nabra f of xn minus 1. Nabra f of xn minus 1 minus this one is Nabra f of the xn over. So you see that 1 over h is the common factor in numerator, the factor out, right? Okay. So now then we got the negative 2h factor out. So we got negative 1 over 2h squared times this. Right? It means that what? We got this. Finally, we got the negative 1 over 2h squared, right? And then another f of the xn minus 1. You see that? F of xn minus 1 minus nabra f of xn. This is equal to 1 over 2h squared. Let me switch the nabra fx minus 1 nabra fxn. So then we're gonna get the one more negative sign. Combine that negative sign, we're gonna get positive sign, right? And then nabra f of the xn minus nabra f of xn minus 1. This is equal to what? 1 over 2h squared, the nabra and the nabra f of xn, which is the 1 over 2h squared, nabra square f of xn. Keep doing that, then what? The difference of xf at xn through the x0, that's going to be 1 over what? Wait a second. So 1 over what? The x, no, I'm sorry. So n factorial, right? So n factorial h to the nth power, and then number to the nth power f of xn. Okay. So in general, we can say that what? So in general, f I mean the f of the xn through the xn minus k, that is equal to 1 over k factorial and the h to the k's power and the nabla k's power f of xn. So then the Pn of x can be expressed as like this: f of xn, okay, is like this: n plus s times what? Yeah, this is delta, right? It should be. Oh, sorry. Today I was really confused about nabla and delta. This is nabla, right? Nabla. This is nabla. Okay, that's nabla. Nabla. Yeah. I'm sorry. Sometimes I always confuse the nabla and delta. So I don't know why, but okay. This is nabla. This is nabla. Okay. Okay. S times what? The nabla f of xn plus s times s plus 1 over 2, and then nabla square f of xn plus through d s times s plus 1 through d s plus n minus 1 over n factorial, and then nabla n's power f of xn. Okay. So now, now back to the lecture note. So now we extend the binomial coefficient, the notation, to include all real values of s by letting like this. Binomial coefficient, we apply the binomial coefficient notation into negative s and k. Then we're gonna get this. And then we're gonna take out the -1 for each the binomial, the numerator, that we're gonna get. We're gonna get this -1 to the k's power times s plus 1 through the s plus k minus 1 over k factorial. Okay. So now then, so applying this formula into the, let's see, applying the this formula into the Pn of x. Okay. So then we could express all the polynomial for each terms in the Pnx in terms of the binomial coefficient notation like this. Okay. So, and then that will, then this can be simplified as like this: sigma f of divided from f and xn plus sigma -1 to the k's power times negative sk binomial coefficient notation, or you can say combination, and then nabla k's power f of xn. Okay. So that's the end of the so the 3.3. Okay. So let me stop here.